Mind the gap.
Platforms are the one place on the railway that passengers are supposed to interact with trains. Getting onto or off of the train involves stepping between the train and the platform. Engineers focus on keeping trains away from structures, signs and signals on the rest of the railway. However, in platforms this is different. Trains need to be able to pass through the platform, sometimes at high speed, without hitting it, but the gap between the train and the platform needs to be minimised to avoid people falling down it. This whole area of risk is known as passenger train interface risk, or PTI risk. So how is this managed? It is managed through two main ways: platform offsets and stepping distance. Within the UK standards, height and offset values between the running edge of the rail and the edge of the platform are given. These are 915mm and 730mm. This ensures a consistent relative position between track and platform across the network. But passengers step onto the train, not the track. This is where stepping distance comes in. This gives a set of values for the distance between the platform and the step or door through which the passengers enter or exit the train. The values are the height of the step, y, the horizontal distance, x, but also a radius, value, z. These values are the maximum allowable and should be as small as possible. By controlling the distance that passengers have to step, it allows for variation in train design, but keeps the gaps and heights passengers are asked to negotiate somewhat consistent between different trains. But, there's always a but. There are other things to consider. In an ideal world, all platforms will be on straight track. When we introduce curves, it's also likely that the track will be canted. This changes a number of things. Mostly it causes trains to lean, which changes the relationship to the platform. If the radius is tight enough, as seen on some London Underground platforms, the end and centre throw of the train becomes an issue. When a train is on a curve, the rigid body of the train causes the ends and the centre to overhang outside the track. The tighter the radius of the curve, the more pronounced this becomes. Depending on which side of the curve the platform is on, a slightly different issue is created when trying to stop the train striking the platform. On the inside, the centre throw has to be accounted for. Therefore, the distance from the platform to the end of the carriage increases. If the platform is on the outside, the issue is reversed where the wide gap appears at the centre of the carriage. This then brings us on to door positions. Stepping distance is only measured at door positions. So, if the platform is used by only one type of train, then only one type of door positions needs to be considered. However, it is very normal, at least in the UK, that platforms are used by a number of different train types, with different door styles and configurations. To illustrate the issues this causes, let's go back to our platform on a curve. If we have a carriage with a door at either end, then it's easier to account for this in design, given that only the ends of the carriages need to be close to the platform. Similarly, if we have a carriage with doors in the centre or at the 1/3 positions, then the centre of the carriage is where the designer will concentrate on the gap. But what if both types of train call at the station? How do you approach this situation? Therein lies the issue to which there isn't a clear answer. The last thing that needs to be considered is gauge clearance. Above all, trains need to not hit the platform. So, all the work around the correct offset and stepping distance can be undone by big wide trains also having to use the line going through the platform. On passenger-only lines, this is not really an issue. However, on railways that is mixed use by both passenger and freight trains, it can be more of a problem. This is because the freight trains differ in their profiles and also how they move laterally when travelling from passenger trains. They often need wider clearances, meaning platforms will have to be further away from the track, increasing stepping distances. So we have a platform that has a wide gap to the train or a high step. What can be done? Well, there are two ways that the relationship between the platform and the track train can be altered. The track can be lifted, slewed either towards or away from the platform, or lowered, or the platform can be altered in the same way. Coper stones at the platform edge can be lifted, lowered, pushed out towards the track, or cut back, or more than likely, a combination of work to both the track and the platform. Small interventions can be made by maintenance teams with tampers, where the track can be lifted and slewed to correct issues. When the track is being renewed is a great time to review platforms. When the track is removed, it allows for lowers to be implemented. However, the overall alignment design that can be implemented may be constrained by other factors in the area. But other things need to be considered when looking to alter platforms. One of the biggest influences is how the platform is constructed. Construction types range from platform surfaces supported by footings, to brick construction, to full precast concrete. This will have an enormous effect on the works that can be done and the price of those works. The gradient of the platform also has to remain suitable for use by all passengers, so the copers cannot be lifted too high and create a steep slope for people to push wheelchairs or pushchairs up. This is known as the platform crossfall gradient. Some level of gradient prevents water pooling on the platform, but a slope towards the edge of the platform risks items rolling onto the track. It is often the case that by correcting one issue, another appears, especially on older platforms not constructed to modern or recent standards. It is often a case of best endeavours in this type of situations, where engineers make a decision on how best to address the issue. So what other options are there to reduce the risk to passengers? There are a number of other options being explored to help reduce the risk. Moving or retractable steps on train that reduce the gap while not adding to the overall profile of the train are one option. Gap fillers. These fill the gap but are soft enough not to damage passing trains. They help avoid items dropping or getting caught in the gap. Moving platforms. Sections of moving platform that extend to fill gaps once the train has come to a stop, particularly useful in a centre throw situation. It's likely that in the future we'll see more of these options used to further reduce the risk to passengers. So there you have it. Passenger train interface risk is managed through maintaining standard offsets between track and the platform. At the doors, the risk is further reduced by measuring and regulating the distances passengers have to step from platform to the door. Various factors need to be considered when looking at trains in platforms, including curvature, door position, gauge clearance, and the platform itself. I hope you found this video useful. If you want to know more about railway engineering, a great place to start is with our Track Components Guide ebook that is available at the link in the description. If you want a little added extra, by signing up to our email list at the link below, you'll get our free Guide to CAN ebook straight into your email inbox. Drop any comments or queries below, hit that like button and subscribe so you don't miss a single video. Thank you.